Hello everyone, welcome to Neso Academy. In the previous lecture, we have studied arithmetic operators, where we performed operations like addition, subtraction, multiplication. But in digital electronics, do we only perform mathematical operations? No. In digital electronics, we mainly deal with logic 0 and logic 1, and we perform operations like NAND, AND, NOT, etc. And these are called logical operators. And in this lecture, we will understand what are logical operators. So, let's start the lecture. In the previous lecture, we have already seen operators are symbols or keywords used to perform operations on data. And in VHDL, there are 6 operators. We have already covered arithmetic operators. Let's see logical operators. Now, logical operators are used to perform logical operations on bits or Boolean values. That is, logical operators are used to perform logical operations on bits, zeros and ones, or Boolean values, true and false. Now, logical operators are used to compare or combine binary values using logic rules. Example, A and B. Now the logic is output becomes 1 when both inputs A and B are 1. Now logical operators work on single bits as well as multiple bit signals or vectors. Now logical operators in VHDL can operate on single bits. Example, if we perform AND operation between 1 and 0, here 1 and 0 both are single bits. Now logical operator work on multiple bit signals or vectors. Multiple bit signals. Example, if we perform AND operation between 101 and 111, here both 101 and 111 are multiple bit signals that we called as vectors. So, logical operators work on single bits as well as multiple bit signals or vectors. There are 7 logical operators in VHDL: AND, OR, NOT, NAND, NOR, XOR, XNOR. We will understand each of them. Let's start with AND operator. Now what is AND operator? AND operator returns 1 only when all inputs are 1. That is, AND operator returns logic high only when all inputs are logic high. For single bit operands A, B, if we perform AND operation between them, the output will be 1 only if both inputs A and B are 1, else output will be 0 for any other input values. Now let's see how to use AND operator in VHDL code. For that, I am creating two signals A and B with standard logic 0, means A is a standard logic with value 0 and signal B is standard logic with value 0. Then I am creating another signal Y with standard logic data type, and this Y will store the result of AND operation between A and B. Now let's see how to use AND keyword to perform AND operation. Here I am assigning A and B and storing the result inside this signal Y. Here A is 0, B is 0, and as per the truth table, if both inputs A and B are 0, the output will be 0. So the signal Y will have the value 0. So I hope you understand single bit AND operation. Now let's see AND operation between two vectors. For that, I am creating two signals A and B with standard logic vector 3 down to 0, means A is a 4-bit standard logic vector and signal B is another 4-bit standard logic vector. Then I am creating signal Y which will store the 4-bit standard logic vector result. Now let's perform the AND operation using the keyword AND. So here I am assigning A and B and storing the result inside the signal Y. Now assume A as 4-bit vector 1, 0, 1, 0 and B another 4-bit vector 1 1 0 0. Now logic operator will perform bitwise operation, means bit by bit operation. So 0 and 0 will be 0, 1 and 0 will be 0, 0 and 1 will be 0, 1 and 1 will be 1. So the output will be 4-bit vector 1 0 0 0. So the signal Y will store the output 1 0 0 0. So I hope you understand how to perform AND operation using AND keyword. Let's see the second operator, OR operator. OR operator returns 1 if at least one input is 1. That is, OR operator returns logic high if at least one input is logic high. Means OR operator will return logic 1 if at least one input is logic 1. Else output will be 0 if both inputs are 0. Now let's see how to use OR operator in VHDL code. For that, I am creating two signals A and B with standard logic data type and assigning A as 1 and B as 0. Then creating another signal Y with standard logic data type, and this Y will store the result for A or B operation. So here I am assigning A or B inside this signal Y. Now A is 1, B is 0, so the output will be 1. Therefore, this signal Y will have the value 1. So this is OR operator. Let's see third operator, NOT operator. NOT operator returns the opposite value of the input. That is, if input is 0, output will be 1. And if input is 1, then output will be 0. So output will be opposite of the input. Now let's see how to use NOT operator. For that, I am creating a signal named A with standard logic 0. Now let's perform NOT operation using the keyword NOT. Here I am assigning NOT of A into the signal Y. If A is 0, the output will be 1. So the signal Y will store output 1. So I hope it is clear how to use NOT operator in VHDL. Now let's see fourth operator, which is NAND operator. NAND operator returns 0 only when all inputs are 1. So NAND operator is opposite of AND operator. Means NAND operator will return 0 only when both inputs are 1. Else output will be 1 for any other input values. Now let's see how to use NAND operator. For that, I am creating two signals A and B with standard logic 0. Signal Y with standard logic will store the output for A NAND B operation. And here I am assigning A NAND B and storing the result inside this signal Y. Now both A and B are logic 0. In this case, output will be 1. So the signal Y will have the value 1. So I hope it is clear how to use NAND operator inside VHDL. Now let's see the fifth operator, NOR operator. NOR operator returns 1 only when all inputs are 0. That is, NOR operator is opposite of OR operator. Let's see the truth table. Output will be 1 when both inputs are 0. Else, output will be 0 for any other input values. Let's see how to use NOR operator. For that, I am creating two signals A and B with standard logic 1. Signal Y with standard logic will store the output for A NOR B operation. And here I am assigning A NOR B inside this signal Y. Now A and B both are 1. And if inputs are 1, then output will be 0. So this signal Y will have the value 0. So I hope it is clear how to use NOR keyword in VHDL code. Now let's see the sixth logical operator, XOR operator. XOR operator returns 1 when the inputs are different. Means XOR operator returns logic high when the inputs are different. Example, if inputs are same 0 and 0, output will be 0. And if inputs are different 0 and 1, the output will be 1. Again, if inputs are different 1 0, output will be 1. And if inputs are same 1 and 1, then output will be 0. So, XOR operator returns 1 when the inputs are different. Now let's see how to use XOR operator. For that, I am creating two signals A and B with standard logic 0. And signal Y with standard logic will store the output for A XOR B operation. And here I am assigning A XOR B and storing the result into this signal Y. Now A and B are 0. And if inputs are 0, the output will be 0. So this signal Y will have the value 0. So this is all about XOR operator. Let's see XNOR operator. XNOR operator returns 1 when the inputs are same. So XNOR operator is opposite of XOR operator. When inputs are same, example 0 and 0, output will be 1. And when inputs are different, 0, 1, output will be 0. And again, when inputs are different, 1 and 0, the output will be 0. And when inputs are same, 1 and 1, the output will be 1. Now let's see how to use XNOR operator. For that, I am creating two signals A and B with standard logic data type 0 and signal Y with standard logic data type which will store the output for A XNOR B operation and storing the result inside this signal Y. Here, both inputs are 0 and when inputs are 0, the output will be 1. So this signal Y will have the value 1. So this is XNOR operator, and I hope you understand all 7 logical operators because logical operators are extremely important in VHDL as digital circuits are mainly built using logical operations on binary numbers. So we are done with this topic of logical operators, which means we are done with this lecture. I will see you in the next one. Thank you.